Okay, welcome back to 10.2. This is part B of our 10.2 videos. And what we're going to be doing today is we're going to take what we did in 10.2a and add variables, right? It's just like being in pre-algebra all over again. You're figuring something out, throw letters at you. Okay, now on your notes, if you're following along with the ones we printed off, you'll see it's got a spot here for your perfect squares list. I strongly recommend you go ahead and write those out again because I strongly recommend that you memorize these numbers, and there's no better way than just writing them all out. If you need to see them again, ignore all that. Here's the list, okay? Pause the video if you need to, and you can copy that down on this sheet as well. You're welcome. Now, we're going to add on to this a simplifying variables list. Okay, so now it's not just about getting that perfect square factor of the number. We're still going to do that, but then we also have to kind of like break up a variable that's taken to some exponent and simplify it so we can pull parts of it out of a radical. And to kind of help with that, we're just going to kind of make a cheat sheet. So we're going to look at some of the simple ones that we're going to see. The first, of course, is if we see the square root of x. All right, and if we see just the square root of x, we can't simplify that. It's already simplified, okay? We're not going to talk about why. We're just going to trust me. It's already simplified, okay? So we'll leave that one as it is. But if we have the square root of x squared, okay, well, the square root of x squared is just x, or x to the first power, if you really want to think about it, okay? Square root of x cubed is x times the square root of x, okay? Square root of x to the fourth is x squared, interesting. Square root of x to the fifth is x squared times the square root of x, okay? Might be seeing a pattern of develop here. Let's try it one more time. The square root of x to the sixth is x cubed, okay? Now, let's take a Dora the Explorer moment here and just pause and think about why that might have just happened. I'm not going to go too deep into it, but it might do you some good to just sit here and ponder how we got from x squared to x. Square root of x to the fourth is x squared. Square root of x to the sixth is x cubed. Something's happening with those exponents. Think about it. We're dividing by 2. And when we can't divide by 2, we have one left over. So that one stays underneath the radical. We're giving you the cheat sheet because the cheat sheet's nice. And, you know, we're not in class to spend 30 minutes on this. But, yeah, we're dividing. Ask us more about that if you're interested. Otherwise, follow the cheat sheet. Now, what is this actually going to look like? Well, looking at number 1 here, we've got the square root of 9 times the square root of x. Square root of x 9. Oh my gosh, try this one more time. The square root of 9x squared y cubed. Good. Okay. What we're going to do is we're going to split this up into 3 parts and then combine them all back in together. That's the way I like to solve these. So I'm going to look at this as the square root of 9 times the square root of x squared times the square root of y cubed. Okay, this will help me kind of really focus my efforts on what I'm doing, because I can look at the square root of 9 and I say, oh, I know what the square root of 9 is. It's 3. Okay, and then this is where my cheat sheet comes in handy. I've got the square root of x squared. If I come right back up here, the square root of x squared is just x. Okay, and then I've got a y. Now, of course, none of these are y's, but we know if I use one variable, I can use another variable. So if all these were y's, well, okay, y cubed, the square root of y cubed would just be y times the square root of y. So times y times the square root of y. And then I'm pretty much done with this problem, right? When it comes to simplifying, all I do is take everything that's outside of the radical and write that as kind of one term, 3xy, times the square root of everything that's inside a radical, which in this case is just y. And that is my answer, okay? I don't have to do anything fancier than that. I'm just simplifying each of those 3 parts, excuse me, okay? So let's look at a trickier one, like number 2. square root of 68, square root of a to the fourth, okay? Split that up. And then for the square root of 68, we have to go back to what we were doing in 10.1. So I have to think about, okay, what were those factors at 68? And what's the biggest perfect square that goes into them? So as a little cheat here, I'm not going to test like 1 times 68 and 2 times 34. I know those aren't perfect squares, but I do know that 4 times, I always forget this one, 14? 68 divided by 4, 17, that's close. 4 times 17, I know that's a perfect square factor of 4, and since 17 is prime, I'm pretty safe to assume that's going to be the biggest one. So I can just take this as square root of 4 times the square root of 17. So this will be 2 square root of 17, okay? And now I've simplified that first part of the original problem. Then square root of a to the fourth, well, now I can just come over to the cheat sheet part of it. Square root of x to the fourth equals x squared. So square root of a to the fourth is just a squared, okay? So I've got 2 square root of 17 times a squared. I never want to leave it like this. So as I mentioned before, take everything outside of a radical sign, put that up front, 2a squared times the square root of 17, okay? And that would be my final answer there, okay? Good time to pause, try 3 on your own, okay? And then come back and check with me, see if you did it right. Welcome back. Again, I'm going to split this up into 3 parts. Square root of 18 times the square root of q to the fourth times the square root of r to the 7th. Ooh, r to the 7th. We didn't do that one. We'll have to go back up to our cheat sheet, but we'll get to that later. Square root of 18, again, look at 18. Factors of 18 that are perfect squares, like 9 and 2. Okay, that's the only one. So we'll just leave it like that. Square root of 9 times the square root of 2. Square root of 9 is 3. So 3 square root of 2 is square root of 18. Looking good there. And then square root of q to the fourth, x, square root of x to the fourth is x squared. So this would be q squared. And then I mentioned earlier a pattern's developing, and sure enough, now we've gone beyond it. R to the 7th. Well, if I come up here, square root of x to the 7th, okay, the pattern, divide by 2, however you want to think about it, we end up with x cubed square root of x. Okay, we get that one little x left over on the inside. So come back down here, and this will just be r cubed square root of r. Okay, now here we got to bring it all together, and this one's going to take a little more work. We've got 3 q squared and r cubed are all outside of a radical. They don't have a radical on top of them, so they'll go up front like so. And then we're going to do one radical for everything that's left underneath. So there's a 2 underneath and an r underneath. So 2r goes underneath altogether. And that's our final answer there. Okay. 4 is an interesting one. We're going to do the same process. Square root of 24 times the square root of a to the fourth times the square root of b squared. Square root of 24, that's the square root of 4 times the square root of 6. Again, as you get more comfortable with this, you start to be able to do that factor part pretty quickly. So 2 square root, 2 square root of 6. And then, again, use your cheat sheet if you have it memorized. Square root of a to the fourth. Looking up here, that's just a squared. And then square root of x squared, square root of b squared is just b. Okay? So then whatever's outside a radical goes up front. 2a squared b. Whatever's inside goes back underneath. That's a 6. That's a 6. Is that a 6? That's a 6. It's a 6. Okay. Okay. What's different about 5? Nothing. There's just 3 variables now. So we got one more step to do. Okay. Square root of 72, square root of x to the 6th, square root of y cubed, square root of z squared. Okay. Square root of 72, we actually did this one on the previous sheet. If you have those notes, square root of 36 times the square root of 2. Okay. And again, I'm listing in my head all the factors of 72, and I'm figuring out that 36 is the biggest perfect square that goes into goes into 72. Okay. Trying to save you guys some time. And square root of 36 is 6.